Hello guys, so today we're gonna be solving the first problem of this year's Polish Math Olympiad. This is a geometry problem. This is gonna be really fun. So, point J is the center of an excircle of the triangle ABC, tangent to the side BC. Points P, B, C and Q lie on a line in this order. Moreover, PB is equal to AB and QC is equal to AC. Prove that the angle BAC plus the angle QJP is going to be equal to 180 degrees. So let's maybe try and draw this problem first of all. So we are given the triangle ABC. That's going to be our triangle ABC right there. It's a beautiful triangle of mine. I'm really bad at drawing. Yeah, so now we are going to make those rays beyond B and C right there. So that's gonna be our B, that's gonna be our C right over here. So that's B, that's C, that's gonna be our A, that's gonna be our, that was G, no, not J, that's gonna be our P, and that's gonna be our Q right here. We also have to extend those sides AC and AB so that when we create this beautiful excircle of ours, it can be also tangent to those. However, I think I have to, oh yeah, I have to move it a little bit. Okay, lovely. And now we have this excircle of ours. It's supposed to be tangent. It has to be a little bit bigger. I just love iPad so much. I mean, drawing is so much quicker, faster and easier. I love it. They should sponsor me. Okay, so and here we have the center of this circle, which is J. We know that those two line segments are of equal length, and also those two line segments are also of equal length. Awesome. So how are we supposed to solve this problem? Well, first of all, let's try and connect the point A and point P to, well, get this beautiful isosceles triangle ABP. I really hope I pronounce it correctly. Please, guys. Okay, and now we know from the properties of excircles that when we connect A to J and then we connect J to B, the resulting angles that are gonna be, let's say, here and here, are gonna be actually dissected. So I would like to call this angle right over there alpha. So I'm really shitty at drawing alpha, honestly. So it's gonna be alpha over 2. That's also gonna be alpha over 2. That really looks like a 2, but it doesn't really matter. So it's gonna be alpha over 2 and alpha over 2. I would like to call this guy right there, let's say gamma, and well, the point here that's gonna be next to the not the point but the angle that's gonna be next to the point B is gonna be called, typically is gonna be beta. Also, so we also know that those angles, this angle right there, the angle that is outside of the angle ABC, is gonna be also dissected. Gonna be also cut in half by the JB's line segment. So here what we're gonna get is that alpha plus gamma all over 2, and here also we're getting alpha plus gamma all over 2 as a measure of the angle. Okay, so let me now go on and prolong this line segment, or maybe I will not go and be doing that in yellow, so you know, just for the consistency's sake, and I connect this line segment here. And so what do we see now? Well, we see a pretty nice thing right there, because those two angles are gonna be equal to each other. I would really love to recall how those angles that lie in this kind of order are called in English, but I'm just too lame for that, so you have to believe me that they are gonna be equal. So here we also have we will also have the alpha plus gamma over 2, and also those two angles are gonna be equal. So here we're also gonna have that that beautiful alpha plus gamma all over 2. And so we know that ABP is an isosceles triangle. Well, what does that mean? That means that those two angles right here and right there are also going to be equal to each other. What does that mean? Well, this means that as we have angles here, here, and here, that are equal to each other in those two triangles, well, also those two angles are gonna have to be equal to each other. It also means that they will have to be 90 degrees each, but it more importantly means that our triangle AB, and let's call this point here maybe F, because why not? So our triangle ABF is going to be actually congruent to the triangle, let's say PBF. Yeah, so the triangle PBF. Well, why is it so? They have all of the angles equal to each other, and also we see that they share this line segment BF. Yeah, so those are actually similar triangles with the K. So the, how did you say, how was it? The quotient of similarity? Or something like this. The constant of similarity equal to 1. Okay, anyway, so those two triangles are congruent. Awesome. So that's going to be triangle PBF right there. Also, this means that those two angles are 90 degrees each. Okay, so let me maybe right now go on and connect by line segment. Oh, that was an awful line segment. The point P with the point J. Unfortunately, I'm going through those beautiful letters right there and through this angle measure, but we don't really care about it. It doesn't affect our problem at all. It doesn't really matter. I just write so shittily. Okay, shitty. Now, what do we do here? Well, we see one pretty nice thing. So, we see that those angles are equal to each other in length. We also see that those two line segments are going to be equal to each other in length. Well, this means something, guys. This means that, and also, well, this line segment is shared by both the triangles AJF and PJF. We see that the triangles AJF and PJF are also going to be congruent to each other. So, the triangle AJF is congruent to the triangle PJF. Well, what does that mean for the triangle, for those triangles to be congruent? Well, it means that the angle FPJ, is going to be equal to the angle JAF, or maybe FAJ. Let's keep the this consistency. Okay, so we see that those two beautiful angles are going to be equal. Okay, well, that's actually pretty nice. And why is that so? You see, what is the measure of the angle JAF? Well, that's the measure of the angle, of this angle right over there, which is half of the alpha. And this angle right over here, which is actually, well, 180 degrees, minus that 90 degrees we have right over here, and minus that alpha plus gamma, which we have right over there. And so, well, that's pretty neat, because what we can say then is that those two angles right here are actually equal to that alpha over 2 plus 90 minus alpha plus gamma over 2. Alpha plus gamma all over 2. Alpha plus gamma over 2? Am I right? Yeah, I think I'm right. Awesome, lovely. Well, what does that stuff mean right now to us? Well, it means that... wait, 90 minus 90, yeah. Am I right? I am right. Okay. That's actually gonna be equal to that 90 degrees. I forgot to put the degrees here and here as well, plus that half of the gamma. Yeah, so what we're getting here is that this angle, the angle AJP, is gonna be equal to 180 degrees, minus, it's gonna be 180 degrees minus both of those angles. So minus the angle, this is not quite the best angle sign I've ever drawn, so the angle FAJ, and minus the angle FPJ, which is actually equal to 180 degrees minus double the 90 degrees plus the gamma over 2, which is equal to, guess what, 180 minus 180 minus, so a plus 2 times gamma over 2, which is equal to gamma. And so what does that stuff mean right there? Well, it means that this beautiful angle. So the angle AJP is going to be equal to gamma, or maybe actually I will do it in red so that we are, oh yeah, we are certain is equal to gamma. Well, that's absolutely perfect, because what can we do now? We could do the exact same reasoning here with the point Q, with the triangle AQC, connect Q to J and do all of that stuff once again to get that the angle AJQ is going to be actually equal to beta. So we've got beta and gamma as our two, we'll be able to, oh yeah, I'm the master of disaster. So that's going to be the gamma, so that's going to be the beta. So we actually have that the angle PJQ is equal to gamma plus beta. But well, the nice thing is that, guess what? Gamma and beta and alpha sum up to 180 degrees. Alpha plus beta plus gamma, because they are angles in the triangle. That's 180 degrees, which means that alpha plus the PJQ angle is equal to 180 degrees right here. That's the end. Hope you enjoyed it, and see you in the next one.